So the title of today's activity is Geographic Winds, or where is it windy and where isn't it windy? This is going to be a piggyback or a complement to this activity here that we did on Friday. You're going to be provided with this worksheet here, and you're going to fill in these conclusions based on the pattern that we now see on this map. The information is presented in order. All you have to do is follow along, listen, and complete the sheet as I go through it. First of all, some key wind ideas. Wind is caused by a difference in pressure. Well, how do you get different pressures? What causes higher pressure? That's cold air sinking. What causes low pressure? Hot air rising. So here's our map, and you have something sort of similar to this. Where does it appear to be windiest in the United States? Well, it certainly looks like mostly in the middle. We got a couple over here off to the sides, but it seems mostly in the middle. And that's what we call the Midwest, or the middle of the country. Now, what did we learn about that part of the country? We know that that's an area where temperatures can change a lot. They can go hot and cold very easily because you're so far away from the water. We've also seen from air masses that you get cold air and hot air kind of meeting there in the middle of the country because we have these two different air masses that kind of intersect there. So that means we have rapidly changing temperatures here. The temperatures can change easily because you're so far from the water.
So here I'm standing in the Midwest part of the United States, more specifically in Nebraska. And this part of the country is where it tends to be windiest. There's a couple reasons for that. First of all, look at the land behind me. It's almost impossibly flat with no mountains, certainly no large buildings or large amounts of trees to stop the wind. So once the wind gets going, there's nothing to break it up. Ergo, this area always tends to be windy because there's nothing to stop the wind. So how does that wind get here? The second reason why it is very windy here is because we're right in the middle of the country, way away from the ocean. So all of this land can get hot and get cold very easily. So remember that wind is caused by differences in pressure, which comes from differences in temperature. So if you're someplace where you can go hot and cold pretty dramatically, like here, far away from the ocean, you're going to get some different pressures and you're going to get some wind moving. Once that wind gets moving, as you can see, there is nothing to stop it back there. The wind is always going to blow. So once again, in summary, the middle part of our country, the Midwest, is where it is windiest because it's very flat with nothing to block the wind, and there's always different temperatures that cause different pressures because we're so far away from the ocean.
So our two conclusions about where it is windiest. It is windiest, number one, in the Midwest. That's what we call this part of the country here, the Midwest.
So let's talk about places where it tends to be windy. First of all, remember that wind is caused by differences in pressure, which is caused by differences in temperature. So if you have one location that is hotter or colder than another, air is rising one place, sinking another, you're going to get differences in pressure, which is going to cause the air to move from high to low pressure. That's what wind is. Well, one of the places where it always tends to be windy is here along the coast, because that water out there is almost always going to have a different temperature than the land behind me. The sun comes out on a nice sunny day like today, and the land's going to get warm, and so the air over the land is going to rise because the air there is getting hot because the land is getting hot. That's going to lead to some low pressure. Well, out here the ocean doesn't change temperature that much, so over the ocean, it's going to be a little bit cooler. Air is going to tend to be sinking, and you're going to have some high pressure. So almost always at the coast, it is somewhat windy because you have different temperatures between the land and the water due to the fact that water doesn't heat up and cool down very easily. So once again, One of the places where it always tends to be windy is at the coast.
So it is also windy at the coast. So we've got two places. It is windiest in the Midwest, and it is windy along the coast. So what causes it to be windy in these two areas? There's two reasons. First of all is the uneven temperatures, which causes uneven pressures. Remember that the water here is almost always going to have a different temperature than the land. So that's going to give you unequal pressures, and you're going to get air moving. In the middle part of the country is where we get the cold air and the hot air interacting. Those two air masses hit each other. So that's going to give you unequal temperatures and unequal pressures. That's what causes wind. The second thing about the coast and the Midwest is friction. Friction is merely things that block the wind. And out here on the ocean, there's nothing out there. So the wind can get going and blow without anything stopping it. And the same thing is true with the middle part of our country. There aren't any mountains and very few trees and certainly no big buildings. So lack of friction means the wind is going to blow a lot and easily. Now these are all examples of places where you wouldn't have as much wind because we have a lot of friction. We have a lot of things that are going to block the wind. So even if it gets going, it's going to hit those buildings or hit the mountains or hit the trees, and you're not going to feel as much wind. Friction is also the reason why windmills have to be raised off the ground to be effective. You have to have windmills up here because if you had the windmill down here, the wind wouldn't get through the trees, or it hit the buildings, or it hit other stuff, and it wouldn't turn the windmill. It's also the reason why smokestacks are always built to be tall. Whether it's a chimney on a house or a smokestack from a power plant, up here the wind is always blowing. Down here the wind is going to hit stuff and not blow as hard. So we want the smoke from a smokestack to go away, and therefore we need to get that smoke into the wind so the wind moves it away. Well, where is it windy? It's going to be windier higher up because there's less friction. Now, why does it not tend to be windy in Atlanta? There's two main reasons. The first of all has to do with temperature. Remember, we pretty much always have warm air because we always tend to have that maritime tropical air mass from the Gulf of Mexico. So we tend to only have the hot part. We don't get a lot of mixing of hot and cold. And we need that difference in temperature in order to cause a difference in pressure, which is going to create wind. Now, here's an extension question that I want you to propose an answer to. When would you expect it to be windiest in our area, and why? I'm going to put the and why. What I'd like you to do is go to Teams and make a reply under the daily agenda to answer this question. When would you expect to be windiest and why here in Atlanta? The map there, the jet stream, gives you kind of a hint as to the answer. The second reason why it doesn't tend to be windy here is we got a lot of hills, we got a lot of trees. So even if the wind does get going, it gets blocked, it gets trapped by the mountains and doesn't get blowing too strong.
Take a look behind me here, and you'll see there's 3 windmills back there behind me. The purpose of those windmills is to generate electricity. The wind blows and it turns the blades, which in turn spins a generator inside of it, which makes electricity. So we've got wind that is being used to produce electricity. Now where I'm at here, you can tell I'm not in Georgia. I'm in the Midwest. I'm in Kansas, where it is very, very flat and there's nothing to get in the way of the wind. So we pretty much all the time have a pretty good wind here blowing, which makes it a great location to put some windmills and make some electricity. Now, you won't see these in Georgia. Why not? The reason is, in Georgia, our wind doesn't blow strong enough or often enough. And even if it does get blowing, it's got too many things like trees and mountains in the way that stops the wind from blowing fast enough in order to make a windmill like this cost effective. So once again, if you know where the wind blows the most, you can put up windmills and have an efficient, free, or almost free generation of electricity, like they do here in the Midwest.
So let's talk about wind and the waves in the ocean. We just said it tends to be windy on the ocean because of the difference in temperatures, and there's nothing in the way out there. So what impact does that have on the waves?
So let's talk about wind and the waves that they produce. All waves are generated by the motion of air moving across the top of the water, which pushes the water that is at the surface. That's why you don't feel waves below the surface, because it's just wind blowing the water across the top. Well, in places like in California, they get really big, powerful waves like you can see back here behind me. The reason is twofold. One, the Pacific Ocean is very large, very deep, has a lot of water in it, tends to stay pretty cool. Well, the land can heat up and cool down pretty easy, especially in the sunlight. So you're going to get a greater difference in pressure and hence a stronger wind. The other important factor, and probably the bigger one, is the fact is that out that direction, the Pacific Ocean goes on for a couple of thousand miles. There's no landmass between here and Asia. So once the wind gets blowing this direction, there's nothing to get in its way. It doesn't hit any mountains, it doesn't hit any trees or buildings, there's nothing. So once the wind gets going, there's nothing to stop it, and hence you get really large waves on the west coast of the United States, like in California.
Now, in the Gulf of Mexico, on the other hand, you get very little wave action. This is typically what we see on a beach in Florida. Not much going on. In Hawaii and California, you might have waves like this caused by really big winds. But we don't get really big winds in the Gulf of Mexico, and hence we don't get big waves. The question is why? What's different? First of all, let's look at the Pacific versus the Gulf. The Pacific Ocean has a cold part to it up here. It also has a hot part down here. So these cold and hot air masses meet, and they have different pressures, because of the different temperatures, which creates some wind. Now, the Gulf of Mexico, on the other hand, doesn't have a cold part. All the Gulf of Mexico has is hot water, because it's a small body of water. It's near the equator. The Gulf of Mexico is an exceptionally hot body of water. Well, without the mixing of the cold and the hot, you don't get a difference in pressure, and hence you don't get any wind. So that's the first reason why the Gulf doesn't have winds like the Pacific Ocean. The second has to do with size. Like I alluded to in the previous video, once the wind gets going across the Pacific Ocean, it's got a long way to pick up speed. The Gulf of Mexico is relatively small, so the waves don't have time to build up to bigger sizes. So there's a summary. Pacific's hot and cold, which means more wind, and the Gulf of Mexico is just always hot. 2, the Pacific is big and the Gulf of Mexico is small. Now we have these two terms here, windward and leeward. If we're talking about an island that's out in the middle of the ocean, you're going to have a wind come across an island, and it tends to always follow a certain pattern. The windward side of an island is the side where the wind is coming off of the water and onto the island. Now, the wind keeps going. It blows over the island and then goes off the other side. That's called the leeward side of the island, or the side where the wind is blowing away from the land out to the water. So here's our definition of windward, is the wind blowing from the water onto the land, and the leeward is where the wind is blowing from the land out to the water. We're going to take a look at Aruba here. And look at the difference between the windward and leeward side of Aruba, because the wind actually really changes what the island looks like on one side versus the other. Here you can see these waves out here. See how they look? Look at some white caps on there. The water looks kind of rough. It's pretty deep because that's the windward side. The wind is blowing this way. then it blows over the island and then keeps going that direction. Now if we look at this side of the island, the water doesn't look very rough. It actually looks kind of shallow too. Let's look at why that happens. Why the difference between the windward and the leeward side?
So looking out there across that ocean, in a straight line from where I'm standing, thousands of miles away is Africa. And there's absolutely nothing between me, where I'm standing here in Aruba, and the continent of Africa. Well, that means there's also nothing to block the wind, because it's all ocean. So there's no trees, no mountains, no other land masses between here and Africa. So that means that those trade winds that are blowing from east to west, close to the equator here, have nothing to get in their way, which means there's almost nothing to stop them, and there's nothing to slow the winds down. So when the wind hits this island of Aruba, they're going exceptionally fast, and faster winds make bigger waves. You can see the waves here, the ocean's pretty choppy. I'm standing on the windward side of the island. This is the side of the island that the winds always blow towards. Now, because the winds blow always on this side of the island, and there's nothing to make the wind slow down, they generate pretty good waves and high surf action. And so that means on this side of the island, we get a lot of weathering and erosion. This side of the island looks something like this. There's no beaches. All of this water just keeps hitting these cliffs and these rocks and chewing them up, taking away the rocks after they break them into smaller pieces, and you see what happens like there. Those are big chunks of the cliff that fell down once the waves eroded, weathered and eroded the part of the rock underneath. So this is what the leeward side of Aruba looks like, and you're going to notice a couple of things different right off the bat. First of all, there's nice pretty white sand on this side of the island, and that's because this side of the island is made up of mostly limestone, which is a nice white rock. So when it breaks down, it forms this nice pretty white sand. Now the other thing of note here is the nice wide sandy beaches, as opposed to the windward side, where the waves are always crashing up against the land and the winds are always really strong onto the shore, and all the sand that does get made gets moved away. This side of the island, the breezes are a lot more gentle and they're moving out to sea. So the waves you can see on this side of the island aren't nearly as big or nearly as rough. So these waves can't take and remove the sand like they can on the other side of the island. So on this side, you get nice, wide, flat, sandy beaches. On the other side, you have rocky, jagged cliffs. And that's the difference between the windward side of an island and the leeward side. And that's generally the case in about any kind of island, whether it's in the Caribbean or Hawaii. You're going to notice a big difference between the windward side and the leeward side.
So here's the leeward and the windward side of Hawaii. Can you identify which side is the side that's getting hit by the waves coming onto the land, and which one is the side where the land is blowing from, where the wind is blowing from the land out onto the water? Well, there's my windward side. Look at these big waves here, because the waves are big because there's a lot of wind on this side. This is where the wind is hitting the land. You can see it makes very sharp, jagged cliffs, rough water. Well, over here on the leeward side, now the wind is blowing that way, and you can see the waves aren't nearly as big. These two pictures were taken on the same day. And you notice over here we got a lot of sand because there aren't big waves to take the sand away. So in your head, kind of make a mental note of the differences between the windward and the leeward side of the island. The windward side, very rough, tends to be jagged and rocky. The leeward side tends to be calm and sandy. So another extension question. Which side of the island do you think you'd be more likely to find your typical tourist hotels on? Think about that. Think about what you saw in the pictures and go to Teams and once again make a reply into the daily agenda in Teams and say, I think I'd find the hotels on the Windward or Leeward side. Which one do you think makes more sense? Once you've completed these 2 extension questions and filled out all of the blanks on that sheet, you can bring it to me for your daily done stamp.